Okay, today we're going to finish the chapter 4. So in previous classes, we have introduced several, actually two Newton's laws, Newton's first law and second law. And here we're continuing to utilize Newton's second law to solve some problems. And at the end of the chapter, we're going to introduce the Newton's third law. Okay, so first let's um, finish the Newton's second law. So section 4.6, let's try to do some free body diagrams practice. Okay, so we have this free body diagram practice because, as we mentioned, Newton's second law, it's the connection or it's the bridge connecting the force and the motion. So in order to study the relationship between the force and motion, we have to first identify what are the forces exerted on your object. So we have to make sure that you're good at making a free body diagram. First, identify what kind of forces are on your object. Okay, so here in our textbook, it gives you 5 steps to draw a free body diagram. Let's see. So first, identify all the forces acting on the objects. So in this step, please remember the first force you need to consider is always the weight. So no matter what happens, if this object is on the earth, so at least you need to consider the weight, and then consider other forces if there is. For example, if there's a normal force or tension force, or let's say some other forces, you need to identify other forces. Second, draw a coordinate system. So usually we know the coordinate system is something like x and y coordinates in two-dimensional situations. Horizontal is x, vertically you put a y label. But remember, sometimes you need to use tilted coordinates. For example, if your project is on the ramp, do you remember that? We have to tilt the coordinates in this way. So this is x, this is y. This is just for convenience. This is the second step. Now the third step, represent the object as a dot at the origin of the coordinate system. So this is what we have been doing all the time. And then draw vectors, and each vector represent one force. And then finally draw labels on each force, and then draw the net force. Okay, so that's all the steps. But that's a theory. Let's use the theory in some practical problems. For example, an elevator lifted by a cable is moving upward and slowing. So which of the options is the correct free body diagram? Okay, I'll give you some time to think about it. Please pause the video for some time, maybe less than 1 minute, to think about which option are you going to choose. Okay. So the correct answer is C, because in this situation, you will only have 2 forces. The first one is Fg, or sometimes, or more generally, we call it weight. Another force is the cable, which is lifting the elevator. Okay. But the difference between A and C is, you see, it's moving upward and it's slowing. So first of all, let's see what's the direction of its velocity. So its velocity is moving upward, means the velocity is going up. And what's the velocity? What's the direction of its acceleration? It's moving up and it's slowing, means the acceleration is against the velocity. So the acceleration is going down. Due to the Newton's second law, do remember that F net equals to what? Do you remember in Newton's second law? F net, the net force equals to ma. A is the acceleration. So the net force and the acceleration, they have the same direction. So if the acceleration is going down, that means the net force is going down. So the weight should be greater than the tension. So the option is C. A and B, they're all wrong. And D is absolutely wrong because there are only two forces, weight and tension force. There's no any other force in this situation.